Julián, gents, welcome to the podcast.
Thank you, Fabian.
Thank you
Nice
for
meeting.
So before we delve into the topic of today, let's learn a little bit more about your journey in the automotive industry. I'm not sure, Jens, would you like to make a start or tell us a little bit more about the past couple of years of engagements in the automotive industry for you?
So you don't want me to start 35 years ago when I started working in automotive, right? I started working for an automotive tier one supplier in the engineering IT, but for the last 25 years, I've been working with NTT DATA, so in IT services and consulting. Last couple of years, mainly on systems engineering, processes, methods, and tools, and also on AI in engineering. Julián, how about you?
Again, thanks for having us, Fabian. My background is quite diverse, actually. So I had various roles and in industries, and that provided me a comprehensive understanding of the automotive industry, AI, and GenAI specifically. Yes, early in my career, I applied complex statistic models in research roles, and then through my academic background, particularly studying industrial engineering and AI, that provided me with a really strong foundation in statistics, maths, and data science. Yes. Then I went into the entrepreneurship world. I had my own startup where we applied machine learning, 3D scanning, and 3D printing in the product development, specifically for the medtech industry. And there we developed a lot of products to help people with disabilities overcome their daily challenges. Yes. Then I worked especially as a data scientist in a tech firm in South America, where I applied AI to solve real-world problems in various complex scenarios, mainly related to customer experience in basically Amazon type of businesses, so marketplace. And last but not least, currently I'm working in NTT DATA as lead consultant, specializing in the interface between AI and systems engineering, with a focus on GenAI, particularly in how to support product development processes with AI technology.
Fascinating. Thanks so much. Both really looking forward to our conversation. Before we delve into the topic of today, Jens, you already mentioned that you've been working in automotive for a number of years now. What are some of the big trends that you see with your clients in the industry more widely at the moment?
Yeah, this CASE acronym has been in your podcast before. So connected, autonomous, shared, and electric mobility as, let's say, 4 cornerstones of automotive strategy, especially on the OEM side. And CASE requires systems engineering. It's not about making a mechanical car anymore. It's mainly about software and electronic challenges. And this is where the innovation happens. This is where the money is, but this is also where the risks are. And introducing processes, methods, and tools to support systems engineering is something that we see, especially on the OEM side. Tier ones were challenged to use automotive SPICE practices before for a long time. But now that the OEMs also dive into software and these topics, all of that is also very relevant for them. The other key trend I see is indeed AI in the product itself, but also in the development processes and methods and tools.
Especially one of the areas you've been doing quite a bit of work, as I understand, is in the product development domain. What are some of the big challenges and trends we see in that particular business area?
Yeah, that's true. We are both coming from the engineering or product development consulting practice in NTT DATA. So that's why that's our focus, right? And what I see is well, the typical challenges of OEMs and Tier 1s, like efficiency and speed and cost of development. When the European customers look at the Chinese competition, they see the need to cut their development process in half, right, from maybe 60 months to 30 months. And this is for a complete vehicle development. But when we talk about software development, this is a much shorter cycle and agile development practices that need to be integrated with the phase gate approach for the complete vehicle. So integrating the software development for things like autonomous driving, infotainment, and software-defined vehicle in the overall product development. That's a big challenge we see. Also, regulatory compliance. When you sell to global markets, you have regulations for South Korea and for Japan and for China and for the European Union. And that's not only product-related requirements that most of the companies know how to deal with, but more and more also requirements affecting the processes, methods, and tools like software update management, cybersecurity management, and well, most recently, again, how to use AI in product development. I guess we will come to that later, Fabian.
No, thanks so much, Jens. Julian, you already mentioned that you've been doing lots of work over the past couple of years in the sort of machine learning and wider AI space. If you would have to describe the state of GenAI in automotive, what are some of the observations you've made over the past couple of years?
That's a really interesting question, and the answer is really dependent on the company you're focusing on. It's really beautiful to see the different status of the companies. And when we speak about the GenAI journey within an automotive company, we are essentially discussing their broader digital transformation journey. Yes, so so GenAI is actually deeply intertwined with the digitalization efforts, as it is the foundation laid by the digitalization that enables the AI technology to truly thrive. Yes, so over the past few years, I've observed that many automotive companies have actually struggled to extract significant value from their digitalization investments. And despite a lot of investments and a lot of initiatives in digital infrastructure and getting this digitalization through the process and products of the companies, the returns, particularly from the AI and business intelligence front, have often been modest compared to what we see in the tech industry. Yes, in the tech industry, data-centered decision-making and AI is really embedded into the whole companies. GenAI, I think, however, is going to change this dynamic. Yes, GenAI is providing companies with a new opportunity to leverage AI in a way that it was maybe previously inaccessible. Yes, especially for those that aren't as digitally mature as the tech companies, real tech companies like Meta, Google, and others, right? So what's fascinating then is how GenAI can offer high value with relatively low barriers of entry. So the company does not need to have a really advanced digitalization in their whole company to already see the benefits. And that is why this has been a game changer for many companies, allowing them to justify further investments in digitalization. And that in turn generates a virtuous cycle, right? So I see more return of investment on these AI applications, then I digitize more, and this digitization allows to generate even more value from these AI technologies. Yeah, so that would be then my observations, and hopefully this technology will really help to materialize this acceleration in these efforts. And then connecting to what Jens was saying, that this GenAI technology allows really to gain this speed and this innovation that at some points lacks in our industry.
You already referred there to some of the, I guess, areas incumbents currently struggle with. What are some of the And then on the other hand, I guess what we see a lot is across the value chain in automotive at the moment is loads of proof of concepts, but a really limited number of them that actually scale and live up to the initial promise. What are some of the use cases you believe that organizations, especially original equipment manufacturers, should look into at the moment?
That's a really accurate appreciation of the reality. Yes, there are a lot of POCs happening everywhere, and you really don't hear a lot of in comparison, right? So if you see it as a pipeline, so there are 10 POCs and 2 of them are being successful. I think that this is normal and this is to be expected. Yes, this funnel happens, and not all of the POCs will be successful. That's why we make POCs. But if we think about what are the places, yes, where GenAI with the current status can thrive is, on my opinion, in automating these really operative tasks that most of the companies have. Yes, in product development, we have a really good example with a lot of tasks that are happening across the V model. And when I speak about the V model, I mean this really typical product development framework that we have in systems engineering that helps basically develop cars, right? And within this V model, in requirements engineering and test management, there are quite a lot of use cases that are really easy to automate. And for example, the requirements extraction processes, requirements classifications, requirements segregation, going across this zigzag curve that is really typical within these systems engineering processes. That is definitely one of the points. That means taking out this overhead producing work and letting the engineers to focus on what matters most, that it's speed, innovation, and really developing. And of course, if we go outside of the product development, yes, customer support, and maybe these more natural language rich use cases are going to thrive. Yeah.
Feels like the sort of wider technology ecosystem feels a little bit like a land grab at the moment, where everyone feels like they have to integrate GenAI types of solutions into their existing product stack, all of the big technology companies, and then there are loads of new entrants that aim to provide models, interfaces, etc., to optimize the development of GenAI solutions.
Yes.
What role do you think some of these partners play today? And then also, how do you believe this will change in the future? Also, maybe taking into consideration hyperscalers like Microsoft Azure, for example.
Yes. So I think again that these POCs face the explosion of these POCs reflect the excitement that the industry has for these technologies and the need that we really have in the automotive industry to get this innovation and this speed. And in this context, exactly as you were saying, there is an important aspect to address, and it's that many players within the automotive industry need some support to effectively create these solutions. And in our work, so partners, hyperscalers, and automotive companies each play a distinct but complementary role in successfully implementing AI solutions. So AI, as you were saying, so hyperscalers, for example, we in NTT DATA, we are partner with Microsoft and to use their Azure platform, and they provide critical infrastructure that enables us to deploy AI solutions at scale without the need for companies to develop, maintain their own large language models. That means this drastically reduces the complexity and cost associated with AI implementation. Hyperscalers then offer robust, scalable environments where AI models can be trained, tested, and deployed efficiently. Of course, imagine if every automotive company should have to create their own large language models. That would be extremely difficult and resource intensive. That's why hyperscalers are there for us. On the other hand, partners like us, NTT DATA, bring specialized expertise that bridge this gap between AI technologies and specific engineering challenges faced by automotive companies. We understand both So the AI aspect and the operational needs of the automotive sector. And then our role is to come such as an accelerator, and we give a first push to help the companies leverage these platforms to effectively and tailor, let's say, AI solutions for their unique needs. And of course, the third obvious part of this partnership is the automotive companies that they have their really good understanding of what are their needs. They have their domain expertise, and this three-step partnership provides a great environment to create really effective and innovative solutions.
Fabian, if you allow one addition to that, right? When we look at the investments that maybe Microsoft, as an example, is taking into AI with the investments into OpenAI, but also into building their data centers and compute, they are highly motivated to bring AI use cases into the field. So
100%.
they also bring funding to clients and to companies like us just to implement use cases and make sure that all these data centers are actually utilized, right?
Yes.
No, thank you so much. Jens, as I understand, you and your team have developed a use case model, especially for AI in engineering. What does a use case model include, and why does it matter for organizations? And what can they generally learn from that?
Yeah, thank you, Fabian, for mentioning this. This was the initial contact, I guess, we had when you stumbled across our blog article on this use case model, right? That we might be able to link in your show notes. But what we basically did is use the V model and collect and organize our experience with customers and looking also at providers and describing use cases around the V model in terms of what's the AI solution approach. It's not all GenAI. There's generative CAD, for example, and more classical machine learning applications as well. And we also define the data that is needed for each use case, because that is sometimes the critical resource, availability of that data, quality of that data. And then the KPIs, especially the business KPIs that are targeted by these use cases, so that we can support customers in identifying the high value use cases with that. We also use that as a reference in order to organize our market and competition information when we see there's a nice solution from a third-party software vendor, for example, and we also use this use case model to organize that.
First of all, thanks for the overview. You already mentioned there that it's really important to prioritize use cases based on the right metrics. And actually, one of the other individuals that I've spoken to for the podcast mentioned that expectation management is really important, so that usually
100%.
Initial expectations are too high, which of course then can't be met if there are certain assumptions that are unrealistic. How would you recommend organizations prioritize use cases the right way using a value-based approach?
Yeah, regarding expectation management, I mean, everyone's looking at this Gartner hype cycle and seeing it going downwards from now on, right? The hype is really high right now. But still, I think the value-based approach for prioritizing the use cases is really important, because automotive is very cost sensitive. And they don't believe in hype. So we maintain a bubble chart for these use cases where we have the business impact and also the feasibility of these use cases on the X and Y axis. and also the estimated implementation effort for each of the use cases in our model. So the ones in the upper right corner are the most promising use cases, right? And we use this as a starting point for every customer. The situation might be a bit different depending on existing infrastructure and data availability and so on. But we typically start with that chart measuring business impact and feasibility and implementation effort for prioritizing the use cases.
You already mentioned initially that it's really important to understand how to optimize using GenAI solutions, our sort of software development cycle, which, as you mentioned, or both of you mentioned, becomes more and more important as even the most old school incumbents become more software driven. How can organizations leverage GenAI solutions to improve their requirements engineering, development, and then test management, which are sort of typically, I guess, three main components of software development?
So in general, I think we need to look at the adoption approach where we see this POC, pilot production sequence is very typical, right? But as Julián described in the requirements engineering domain, there are many sub-use cases that lend themselves very well to GenAI because requirements are mainly text-based. And the tables and charts and so on we see in requirement specifications are also nicely handled by current multimodal LLMs, right? So that's a good starting point. In software development, things like GitHub Copilot have been around for more than 2 years. I would consider this the most mature domain compared to geometry and electrical engineering use cases. So code generation, code analysis, refactoring, test automation, these are all use cases that are there now. I mean, we also have a lot of software developers in NTT DATA, right? No one codes that from scratch. This is an efficiency improvement that cannot be neglected.
Julián, we've already spoken briefly about the importance of scaling from proof of concept to a global solution, which is of course where the value sits in terms of, I guess, number of users times impact this has on an individual. What are some of the sort of typical pitfalls you see when it gets to the sort of scaling phase, maybe also considering areas like change management, and what are some of the recommendations from an implementation standpoint that you would highlight to increase the success rate and potentially resource that is needed to successfully scale?
Perfect. Great question. So I think that in order for a POC to be able to scale, it has to be a successful POC, right? So it has to go over this evolutionary process where some POCs will just fail, right? And that means I think that the key difference between those POCs that are successful and those who aren't is proving successfully that they bring business value into the equation. So it means and going back to one of the points that you were making before, when you decide what is the objective of this first POC, you have to really set correctly the goal. Business focus on first, right? Like Jens was saying, we have to pick the scope correctly so that if we have a successful POC, then this will be something that already can be implemented and can already bring some value to the company. And that kickstarts the next step, that it's scaling, and where you just already said, it's a phase where most projects as well fail. And this transition to a fully scaled enterprise-grade solution is really challenging, as you were saying. First, I think that the most important topic is to manage the expectations from the outset, right? So a successful POC shows us that the AI solution can work, but it's a controlled environment with limited scope. Moving to a production environment means scaling up the solution to handle real world conditions with real substantial additional resources that are needed, both technical and human. And with that means as well that the speed of development from a POC to a productive environment usually decreases. And that's why expectation management and clearly defining, okay, so POC, this scaling up of the POC will take maybe a little bit more time than this POC. This is something that really has to be well communicated from the start on. Yeah, and I think that here, so having a partner such as Microsoft is so useful, right? Because cloud platforms are natively able to scale up. And that brings me to the second point. That is, if you build a POC, develop it with scalability in mind from the outset. This means select the right technologies that are natively scalable, use your cloud platform or any technology that actually allows you to scale. But something that really holds up on this speed is having to start all over again because, oh, great, we found out the POC was super successful, but it really is useful for a really small amount of scenarios and really a couple of users. Build your POC with scalability first. And then, of course, there are a lot of challenges that are outside of these technical aspects. And organizational change management is equally, if not more important than this, right? And I think that introducing AI into any organization often triggers concern and resistance, particularly around job security and fear of the unknown. We all know, hey, AI is going to replace us. It's such a scary situation. The space of improvement is so big that we really think that people has to be hopped on board in this transition. That's why we advocate for a comprehensive change management strategy that involves clear communication, training, and gradual integration of AI into existing workflows. It's about helping the organization evolve alongside this technology and not destroying jobs, not destroying life beings, right? And of course, it's really important as well as a last point to stress the topic of AI governance. Yeah, so AI governance means if we have a successful POC where we scale up the solution, this solution should be contained within a cohesive strategy. Yes, we should ensure that the right frameworks are implemented to manage data, monitor AI performance, and ensure that all AI activities align with the broader strategic goals of the organization.
Thank you so much. Initially, both of you mentioned or referred to the importance of systems engineering in automotive more widely. Yeah. When we briefly spoke last time, you mentioned systems engineering co-pilot. First of all, what is that and why does it matter as it relates to the implementation and scaling of GenAI solutions?
Yeah, great. So we were actually observing this trend of systematic POCs, and actually before that trend, we were observing that before this POC explosion, there was a PowerPoint explosion, right? Where many people were making beautiful PowerPoint presentations showing how cool things could be, but not a lot of real applications were found. And that's why we said, let's really develop our systems engineering copilot, that it's a GenAI powered tool that we developed to assist engineers in streamlining these complex product development processes in the automotive industry. Yes, it actually began as this demo to show how AI can be integrated into these systems engineering workflows. For example, what I was saying before, to automate routine tasks such as generating test cases, verifying requirements, and integrating GenAI to the existing tooling, such as Jira, Codebeamer, or other ALM systems. But then we realized that the automotive industry players are different. They all have their own specific needs, but there is a core amount of problems that the industry has. And that's why it became clear that this tool had the potential to do much more than we initially envisioned as a simple demo. So we made it grow from a simple POC into a comprehensive assets that tackle these common challenges, and allows us to leverage the technology provided by Microsoft, specifically Azure platform, to create a modular and flexible solution that is easily tailored to a specific client needs. So we see Systems Engineering Copilot as an accelerator that allows us to scale rapidly and handle large volumes of data and create and implement these client-specific use cases in each one of our clients. Also, actually, we are successfully using this asset to create POCs in way less than 3 months, and it will allow us as well to scale up this from a POC into a productive environment in less than 6 months as well. So that is really it's really something promising that we have, and it's already helping us generate a lot of value to our clients.
Jens, in automotive, we've of course got so many different problems across basically all business areas. So in design and engineering, in industrial operations, in customer and finance and HR, they all face so many different challenges, and many of them arguably could be addressed using a form of GenAI solution. I guess a natural question is, just from a sort of value optimization standpoint, what specific areas should an automotive original equipment manufacturer focus on to improve what specific value metrics to, I guess, maximize the value they can generate from GenAI?
Yeah, I agree. There are lots of challenges. That's why we love working in automotive, right? It's never boring. And I think the main KPIs that we are watching from a product development perspective is the time to market and the efficiency in terms of manpower and costs needed for product development, but also the quality that can, for example, be measured in terms of how many changes are needed at what point in the product life cycle. But when we dive deeper into areas like requirements engineering, we also measure the quality of the requirements using GenAI. You typically have criteria such as requirements need to be testable. You want to avoid filling words. They need to be atomic, and they shouldn't contradict other requirements. So there's a whole list of quality criteria for your requirements, and we have solutions to measure a whole requirement space against that and optimize the requirements, so suggest better formulations for the requirements.
As you already alluded to initially and just now, there are also profound implications for the workforce from a capability and skills and learning and development standpoint. What are some of the trends you've seen at the moment in terms of upskilling the workforce, and how do you believe this might change over the coming years, as arguably everyone need to, I guess, receive some form of upskilling, no matter where they sit in the organization as it relates to GenAI?
Yeah, So one thing I see is that this is nothing you want to learn just on the theory level, right? So hands-on learning is the most efficient way for that. And things are also still in an early phase and changing fast. So it's not a one-time training effort. It's something that you should integrate into the daily work of people. So this concept of a co-pilot and handing some tasks to this co-pilot, I really like that. I think one trend is also that companies are still struggling with the policies, so the governance topic that Julián mentioned. So when you are as an employee not clear if you are allowed to use ChatGPT or for what can you use it and not, then this is a big blocker in mastering this learning curve.
Just to wrap up the conversation, given that we're almost out of time, one question to both of you, and you can decide who goes first. What do you believe are the top 3 future trends as it relates to GenAI in automotive? And then secondly, what will be your top 3 recommendations to senior leaders in charge of the data and AI organizations at either original equipment manufacturers or other partners across the value chain?
Julián, do you
Yeah,
want
sure.
to comment on the trends?
Yeah, for sure. So with respect on the trends, I think that the first trend that we're going to pick up really fast is multimodality. The fact that we are interacting with these large language models not only through text, but as well through voice and through video, increases immensely the amount of impact that this technology will have on our products. Yes. So from the product perspective, I expect an explosion of use cases being implemented within our cars, such as being able to interact with our car in a way seamless way that we are currently having, and that as well our car is way more aware of our environment, right? So that the vision capabilities that our cars currently have are not only used for driving and automated driving, but as well to give us information about our context. And I think that's going to be definitely one of the exciting trends that we're going to see in terms of the product and in terms of the company, on the company implementation of the company side of the implementation. It's going to definitely happen that we are all going to use AI in really a lot of different ways, both from a top-down approach where managers give us tools that have AI embedded and that take some work from us so that we can concentrate in more value-driven work, and at the same time some bottom-up changes, right? And that means that we're going to bring our own GenAI to work, and we're going to allow AI to influence and help us do our daily job. And if I have to say then these 3 recommendations to the top managers is, please let your workforce freely decide what is the best use case for GenAI for themselves. That means this bottom-up approach is really important for GenAI to get the capillarity and to get and to be spread all around the company, and at the same time give a clear directive from the top down and integrate these technologies within your current IT ecosystem. And that is exactly what we're doing with Systems Engineering Copilot. Yeah, allow your IT ecosystem to grow through these tools, and allow your colleagues and your workforce to creatively use this technology to be more productive and more efficient in their work.
Thanks so much, Julián. Jens, final word, over to you.
Yeah, thank you. I think these were great points. I would add maybe one trend is trustworthy AI. As NTT DATA, we have partnered with the TÜV Süd on this. This is about explainable AI and testing. I think this is really important, especially when you want to use AI in a product, right, for autonomous driving use cases, for example. So trustworthy AI. I also see this thinking beyond use cases. You know, we have this nice model with 27 use cases just for product development, a lot of sub-use cases there, but you don't want to have an individual architecture, each with their own large language model and fine-tuning and so on for 27 use cases. You need some overall architecture, otherwise this becomes not maintainable and also not usable. And well, when you ask for recommendations, I would like to cite Ethan Mollick. He has a nice book called Co-Intelligence, so recommended reading, but he has some principles, and the first one is always invite AI to the table, right? You don't have to take over the results, especially not blindly, but always consider using that in brainstormings, in idea generation, in communication, and so on. Always invite AI to the table.
Thank you so much, both Jens and Julián. It's been a fascinating and super insightful conversation.
Thank you, Fabian,
Thank you
for
back,
having us.
Fabian.
Good luck with the podcast.